Welcome to part 3 of our video presentation on Tutorial D. In this part I will show you how to create an Excel-based decision support system for the case study for the CV Fitness company that we talked about in the previous part. This decision support system will be used in conjunction with the Excel Solver feature in the fourth part of this video presentation to show you how certain parameters, or more specifically the total cost parameter, can be optimized. But for now we'll just create the setup. We'll enter the necessary formulas so that all the cells, all the variables within this decision support system are appropriately linked. Now the first column we're going to work on is the column called volume required. Now volume required depends on the quantity and type of goods or products that are to be shipped to a particular store location, and also the volume that each of those products will take within a truck, or the volume that is required to transport a particular product. So the formula will be something like this. We'll have to multiply each of these products, the quantity for each of those products, by the volume for each of the products. Now the volume for each of the products needs to be treated as a constant cell, so that when we drag down this formula, this particular value of volume doesn't change. So that's why it should be something like this, times. First of all, we'll select this cell for exercise bikes. So this is the volume for exercise bikes, and then we'll have to make it constant. We'll put $signs here. So this is how much volume we will need to transport exercise bikes for this particular store location, plus the volume that we need for transporting cross trainers, times this cell. Again, don't forget to make it a constant, plus this value multiplied by volume. Again, it has to be constant. So this is the total volume required to transport all those products to the Philadelphia store. So here's the value, the total. And then what we will do, we'll just drag it down, and we'll have all those volumes calculated. By the way, this Excel sheet, the skeleton, is available for you to download through Canvas, so you don't have to enter all those case values, and you don't have to deal that much with formatting. But nevertheless, you understand that certain formatting features will be useful. For example, some columns or some cells should be formatted as currency, and I think they already are formatted. Yeah, you see it's a currency. Some of them are percentages, like this column. But anyways, all those columns, all those formatting elements are already entered in the skeleton. Okay, so basically we're saying that this is the volume required to transport all those goods for each of those stores. Now, to make sure that we don't forget what we're doing in this column, here we have like a totals row. So we'll just create a sum of all the volumes required. So that will give us the total volume that we need to transport. Now this column called trucks, it's highlighted with yellow. So basically it means those are the cells that we will change in order to optimize or minimize the total cost. So basically here we need to enter the number of trucks that we will need to transport that required volume. Now for now we're not going to worry about these values. We're just going to enter once as seed. So basically we're saying our starting guess is that we will need one truck to transport this volume. Okay, so we'll just put once. And here we'll create a total cell that will be the sum of all trucks that we need for 1 week of shipments. Okay, volume for trucks, this is a constant. It's set at 1,500 cubic feet. So we enter it like this, and then please don't forget to make it a constant. So we hit enter, and then we just copy this for all trucks. One thing that I forgot is that it has to be multiplied by the quantity of trucks, because otherwise, if we change this parameter, this volume for trucks will not change. So I'll just put it like this, but the value for now will be the same, but it has to be multiplied by the quantity of trucks. And here we have sum of all volumes for all trucks. Now, tractor trailer is the same thing. You see it's highlighted with yellow, meaning those are the cells that will be changing in order to find an optimal combination so that the total cost is minimized. So for now we'll just enter 1. The volume for tractor trailer, again, similarly, we'll use this value. Again, please don't forget to make it a constant, and we'll multiply it by the quantity of tractor trailer. So that will give us volume per each individual tractor trailer combination for each of those stores. So here we'll calculate sum, the total of all volumes, and here we forgot to calculate sum of all tractor trailers that we're going to use. Okay, so here we have total vehicle capacity, meaning capacity that is delivered by both trucks and tractor trailers. So in order to calculate that, we just need to add this volume to this volume. To this volume. That will be our total capacity. And then we just drag it down. And here we have capacity for all vehicles. So it's a sum of all values here. Okay. Now in this column we have percent of vehicle capacity utilized. Basically we want to make sure that we see how much available volume of tractor trailers and trucks that we assign to a particular store delivery, how much it's actually utilized. Now that value can be more than 100% in case it looks like we have more volume of goods to be delivered than the volume of trucks and tractor trailers that is currently assigned. So in that case it will be more than 100%, meaning we're overutilizing our capacity. But this is calculated as follows: needed volume required divided by the total capacity. So this is the total capacity that comes from one truck and one tractor trailer, and this is what we need in total. So you see in this case it's 130%, meaning we exceed the available capacity as reflected here. So we'll calculate all those things. Now here, instead of having sum, because it's not very meaningful, we'll have average capacity. So we'll have average of all these values. Okay, so the average capacity is 134%, which kind of means that on average we don't have enough trucks to meet all those volume requirements. Okay, now we need to deal with the shipping cost. So the shipping cost will be based, the calculation of the shipping cost will be based on several parameters. Well, one second. Remember that the shipping cost for each of the truck and each of the trailer tractor is based on the mileage. Okay, so what we need to do, we need to multiply the miles, okay, by the number of trucks right here, and then we will multiply by the cost per mile per truck. So this is $1. So that will be the shipping cost from trucks. Okay. Now on the top of that, we need to add how much it will cost us to use tractor trailers. So we multiply the number of tractor trailers by the mileage again, and by the cost per mile that we need to have for each of the tractor trailers. So that's $1.30. So this is our calculation. And if we extend this formula, something wrong. I think we didn't enter properly. One second. Oh yeah, the mistake that I made is that all those things, they need to be constant. I'm talking about operating cost per mile. So the cell D5 and D6, they need to be constant, so that's why it gives us an error. Okay, so now it should work. Yeah, so this looks right. Okay, and here we have total cost, and we'll calculate total cost by creating a sum of all these values. Okay. So basically, this is our decision model so far. Those are the cells that we will change, and this is the value that needs to be optimized, or more specifically to be minimized, because we're interested in minimizing cost for each of those weeks. What you can do, we're about to finish this part of tutorial, the video presentation. What you can do on your own, you can just try to find different combinations. Now, there are some constraints, because you need to understand that you cannot exceed, the total number of trucks that you have is 12, and the total amount or the total number of tractor trailers that you have is 6, so you cannot exceed that. Also, you want to make sure that the capacity is at 100% or below, because you cannot ship something that has required volume that is greater than the total volume available from your trucks and trailers. So you can put those numbers and see what happens with cost. So that would be like a manual way to find an optimal combination of trucks and trailers to meet the weekly demand from all of those stores. So try that out. Try different combinations of trucks and trailers without exceeding the total number of trucks and trailers that you have, and also making sure that the capacity, the percentage of vehicle capacity utilized is not greater than 100%. So see what happens. Okay, so this concludes part 3 of our video presentation. Thank you for listening.